Biometrics.
Biometrics refers to the quantifiable data related to human characteristics and traits. Biometrics identification is used in computer science as a form of identification and access control. It is also used to identify individuals in groups that are under surveillance. Biometric identifiers are the distinctive, measurable characteristics used to label and describe individuals. Biometric identifiers are often categorized as physiological versus behavioral characteristics. Physiological characteristics are related to the shape of the body. Examples include, but are not limited to fingerprint, face recognition, DNA, palm print, hand geometry, iris recognition, retina and odor scent. Behavioral characteristics are related to the pattern of behavior of a person, including but not limited to typing rhythm, gait, and voice. Some researchers have coined the term behavior metrics to describe the latter class of biometrics. More traditional means of access control include token-based identification systems, such as a driver's license or passport, and knowledge-based identification systems, such as a password or personal identification number. Since biometric identifiers are unique to individuals, they are more reliable in verifying identity than token and knowledge-based methods. However, the collection of biometric identifiers raises privacy concerns about the ultimate use of this information.
Biometric functionality.
Many different aspects of human physiology, chemistry or behavior can be used for biometric authentication. The selection of a particular biometric for use in a specific application involves a weighting of several factors. Jane al. 1999, identified 7 such factors to be used when assessing the suitability of any trait for use in biometric authentication. Universality means that every person using a system should possess the trait. Uniqueness means the trait should be sufficiently different for individuals in the relevant population such that they can be distinguished from one another. Permanence relates to the manner in which a trait varies over time. More specifically, a trait with good permanence will be reasonably invariant over time with respect to the specific matching algorithm. Measurability, collectability, relates to the ease of acquisition or measurement of the trait. In addition, acquired data should be in a form that permits subsequent processing and extraction of the relevant feature sets. Performance relates to the accuracy, speed, and robustness of technology used. See Performance section for more details. Acceptability relates to how well individuals in the relevant population accept the technology such that they are willing to have their biometric trait captured and assessed. Circumvention relates to the ease with which a trait might be imitated using an artifact or substitute. No single biometric will meet all the requirements of every possible application. The block diagram illustrates the 2 basic modes of a biometric system. First, in verification, or authentication, mode the system performs a one-to-one comparison of a captured biometric with a specific template stored in a biometric database in order to verify the individual is the person they claim to be. 3 steps are involved in the verification of a person. In the first step, reference models for all the users are generated and stored in the model database. In the second step, some samples are matched with reference models to generate the genuine and imposter scores and calculate the threshold. Third step is the testing step. This process may use a smart card, username or ID number, for example PIN, to indicate which template should be used for comparison. Positive recognition is a common use of the verification mode, where the aim is to prevent multiple people from using same identity. Second, in identification mode the system performs a one-to-many comparison against a biometric database in an attempt to establish the identity of an unknown individual. The system will succeed in identifying the individual if the comparison of the biometric sample to a template in the database falls within a previously set threshold. Identification mode can be used either for positive recognition, so that the user does not have to provide any information about the template to be used, or for negative recognition of the person, where the system establishes whether the person is who she, implicitly or explicitly, denies to be. The latter function can only be achieved through biometrics since other methods of personal recognition such as passwords, pins or keys are ineffective. The first time an individual uses a biometric system is called enrollment. During the enrollment, biometric information from an individual is captured and stored. In subsequent uses, biometric information is detected and compared with the information stored at the time of enrollment. Note that it is crucial that storage and retrieval of such systems themselves be secure if the biometric system is to be robust. The first block, sensor, is the interface between the real world and the system. It has to acquire all the necessary data. Most of the times it is an image acquisition system, but it can change according to the characteristics desired. The second block performs all the necessary pre-processing. It is to remove artifacts from the sensor, to enhance the input, for example removing background noise, to use some kind of normalization, etc. In the third block necessary features are extracted. This step is an important step as the correct features need to be extracted in the optimal way. A vector of numbers or an image with particular properties is used to create a template. A template is a synthesis of the relevant characteristics extracted from the source. Elements of the biometric measurement that are not used in the comparison algorithm are discarded in the template to reduce the file size and to protect the identity of the enrollee. During the enrollment phase, the template is simply stored somewhere, on a card or within a database or both. During the matching phase, the obtained template is passed to a matcher that compares it with other existing templates, estimating the distance between them using any algorithm, for example Hamming distance. The matching program will analyze the template with the input. This will then be output for any specified use or purpose, for example entrance in a restricted area. Selection of biometrics in any practical application depending upon the characteristic measurements and user requirements. We should consider performance, acceptability, circumvention, robustness, population coverage, size, identity theft deterrence in selecting a particular biometric. Selection of biometric based on user requirement considers sensor availability, device availability, computational time and reliability, cost, sensor area and power consumption.
Multimodal biometric system.
Multimodal biometric systems use multiple sensors or biometrics to overcome the limitations of unimodal biometric systems. For instance, iris recognition systems can be compromised by aging arides and finger scanning systems by worn-out or cut fingerprints. While unimodal biometric systems are limited by the integrity of their identifier, it is unlikely that several unimodal systems will suffer from identical limitations. Multimodal biometric systems can obtain sets of information from the same marker, that is, multiple images of an iris, or scans of the same finger, or information from different biometrics, requiring fingerprint scans and, using voice recognition, a spoken passcode. Multimodal biometric systems can integrate these unimodal systems sequentially, simultaneously, a combination thereof, or in series, which refer to sequential, parallel, hierarchical and serial integration modes, respectively. The interested reader is pointed to TUBISA for detailed trade-offs of response time, accuracy, and costs between integration modes. Broadly, the information fusion is divided into three parts: pre-mapping fusion, midst mapping fusion, and post-mapping fusion late fusion. In pre-mapping fusion information can be combined at sensor level or feature level. Sensor-level fusion can be mainly organized in three classes: 1. Single sensor multiple instances, 2. Intra-class multiple sensors, and 3. Inter-class multiple sensors. Feature-level fusion can be mainly organized in two categories: 1. Intra-class and 2. Inter-class. Intra-class is again classified into four subcategories: A. Same sensor same features, B. Same sensor different features, C. Different sensors same features, and D. Different sensors different features.
Performance.
The following are used as performance metrics for biometric systems. False acceptance rate or false match rate, FAR or FMR, the probability that the system incorrectly matches the input pattern to a non-matching template in the database. It measures the percent of invalid inputs which are incorrectly accepted. In case of similarity scale, if the person is an imposter in reality, but the matching score is higher than the threshold, then he is treated as genuine. This increases the FAR, which thus also depends upon the threshold value, false rejection rate or false non-match rate, FR or FNMR, the probability that the system fails to detect a match between the input pattern and a matching template in the database. It measures the percent of valid inputs which are incorrectly rejected, receiver operating characteristic or relative operating characteristic, ROC. The ROC plot is a visual characterization of the trade-off between the FAR and the FRR. In general, the matching algorithm performs a decision based on a threshold which determines how close to a template the input needs to be for it to be considered a match. If the threshold is reduced, there will be fewer false non-matches but more false accepts. Conversely, a higher threshold will reduce the FAR but increase the FRR. A common variation is the detection error trade-off, DET, which is obtained using normal deviation scales on both axes. This small linear graph illuminates the differences for higher performances, rarer errors, equal error rate or crossover error rate, EER or CER, the rate at which both acceptance and rejection errors are equal. The value of the EER can be easily obtained from the ROC curve. The EER is a quick way to compare the accuracy of devices with different ROC curves. In general, the device with the lowest EER is the most accurate. Failure to enroll rate, FTE or FER, the rate at which attempts to create a template from an input is unsuccessful. This is most commonly caused by low-quality inputs. Failure to capture rate, FTC, within automatic systems, the probability that the system fails to detect a biometric input when presented correctly. Template capacity, the maximum number of sets of data which can be stored in the system.
History of biometrics.
The earliest cataloging of fingerprints dates back to 1891 when Juan Bucetich started a collection of fingerprints of criminals in Argentina. The history of fingerprints.
Adaptive biometric systems.
Adaptive biometric systems aim to auto-update the templates or model to the intra-class variation of the operational data. The twofold advantages of these systems are solving the problem of limited training data and tracking the temporal variations of the input data through adaptation. Recently, adaptive biometrics have received a significant attention from the research community. This research direction is expected to gain momentum because of their key promulgated advantages. First, with an adaptive biometrics system, one no longer needs to collect a large number of biometric samples during the enrollment process. Second, it is no longer necessary to re-enroll or retrain the system from scratch in order to cope with the changing environment. This convenience can significantly reduce the cost of maintaining a biometrics system. Despite these advantages, there are several open issues involved with these systems. For misclassification error, false acceptance, by the biometrics system, cause adaptation using imposter sample. However, continuous research efforts are directed to resolve the open issues associated to the field of adaptive biometrics. More information about adaptive biometric systems can be found in the critical review by Ratani al.
Current, emerging and future applications of biometrics. India's National ID Program.
India's national ID program called Aadhaar is the largest biometric database of the world. It is a biometrics-based digital identity assigned for lifetime, verifiable online instantly in public domain, at any time, from anywhere, in a paperless way. It is designed to enable government agencies to deliver retail public service securely based on biometric data, fingerprint, iris scan and face photo, along with demographic data, name, age, gender, address, parent-spouse name, mobile phone number, of a person. The data is transmitted in encrypted form over Internet for authentication, aiming to free it from limitations of physical presence of a person at a given place. It has enrolled about 550 million residents and assigned 480 million or higher numbers as of November 7, 2013. It aims to cover entire population of 1.25 billion in a few years.
Recent advances in emerging biometrics.
In recent times, biometrics based on brain, electroencephalogram, and heart, electrocardiogram, signals have emerged. The research group at University of Wolverhampton led by Ramasamy Palaniappan has shown that people have certain distinct brain and heart patterns that are specific for each individual. The advantage of such futuristic technology is that it is more fraud-resistant compared to conventional biometrics like fingerprints. However, such technology is generally more cumbersome and still has issues such as lower accuracy and poor reproducibility over time.
Proposal calls for biometric authentication to access certain public networks.
John Mike McConnell, a former Vice Admiral in the United States Navy, a former Director of U.S. National Intelligence, and Senior Vice President of Booz Allen Hamilton promoted the development of a future capability to require biometric authentication to access certain public networks in his keynote speech at the 2009 Biometric Consortium Conference. A basic premise in the above proposal is that the person that has uniquely authenticated themselves using biometrics with their computer is in fact also the agent performing potentially malicious actions from that computer. However, if control of the computer has been subverted, for example in which the computer is part of a botnet controlled by a hacker, then knowledge of the identity of the user at the terminal does not materially improve network security or aid law enforcement activities. Recently, another approach to biometric security was developed. This method scans the entire body of prospects to guarantee a better identification of this prospect. This method is not globally accepted because it is very complex and prospects are concerned about their privacy.
Issues and concerns. Privacy and discrimination.
It is possible that data obtained during biometric enrollment may be used in ways for which the enrolled individual has not consented. For example, biometric security that utilizes an employee's DNA profile could also be used to screen for various genetic diseases or other undesirable traits. There are three categories of privacy concerns. Unintended functional scope. The authentication goes further than authentication, such as finding a tumor. Unintended application scope. The authentication process correctly identifies the subject when the subject did not wish to be identified. Covert identification. The subject is identified without seeking identification or authentication, that is a subject's face is identified in a crowd.
Danger to owners of secured items.
When thieves cannot get access to secure properties, there is a chance that the thieves will stalk and assault the property owner to gain access. If the item is secured with a biometric device, the damage to the owner could be irreversible, and potentially cost more than the secured property. For example, in 2005, Malaysian car thieves cut off the finger of a Mercedes-Benz S-Class owner when attempting to steal the car.
Cancelable biometrics.
One advantage of passwords over biometrics is that they can be reissued. If a token or a password is lost or stolen, it can be cancelled and replaced by a newer version. This is not naturally available in biometrics. If someone's face is compromised from a database, they cannot cancel or reissue it. Cancelable biometrics is a way in which to incorporate protection and the replacement features into biometrics. It was first proposed by Rather al. Several methods for generating new exclusive biometrics have been proposed. The first fingerprint-based cancelable biometric system was designed and developed by Tulyakov al. Essentially, cancelable biometrics perform a distortion of the biometric image or features before matching. The variability in the distortion parameters provides the cancelable nature of the scheme. Some of the proposed techniques operate using their own recognition engines, such as TOA al and Savides al, whereas other methods, such as DAB al, take the advantage of the advancement of the well-established biometric research for their recognition front-end to conduct recognition. Although this increases the restrictions on the protection system, it makes the cancelable templates more accessible for available biometric technologies.
Soft biometrics.
Soft biometrics traits are physical, behavioral or adhered human characteristics, which have been derived from the way human beings normally distinguish their peers, for example height, gender, hair color. Those attributes have a low discriminating power, thus not capable of identification performance. Additionally, they are fully available to everyone, which makes them privacy safe.
International sharing of biometric data.
Many countries, including the United States, are planning to share biometric data with other nations. In testimony before the U.S. House Appropriations Committee, Subcommittee on Homeland Security on Biometric Identification in 2009, Kathleen Kraninger and Robert A. Mockney commented on international cooperation and collaboration with respect to biometric data, as follows. According to an article written in 2009 by S. Magnuson in the National Defense magazine entitled Defense Department Under Pressure to Share Biometric Data, the United States has bilateral agreements with other nations aimed at sharing biometric data. To quote that article,
governments are unlikely to disclose full capabilities of biometric deployments.
Certain members of the civilian community are worried about how biometric data is used, but full disclosure may not be forthcoming. In particular, the unclassified report of the Defense Science Board Task Force on Defense Biometrics states that it is wise to protect, and sometimes even to disguise, the true and total extent of national capabilities in areas related directly to the conduct of security-related activities. This also potentially applies to biometrics. It goes on to say that this is a classic feature of intelligence and military operations. In short, the goal is to preserve the security of sources and methods.
Countries applying biometrics.
Countries using biometrics include Australia, Brazil, Canada, Gambia, Germany, India, Iraq, Israel, Italy, Netherlands, New Zealand, Norway, Ukraine, United Kingdom, and United States. Among low-middle-income countries, roughly 1.2 billion people have already received identification through a biometric identification program.
In popular culture.
Sneakers, 1992 film, 1992 film starring Robert Redford. My Voice is My Passport, Red, film, a 2010 American action comedy film based on the comic book miniseries. Using a photocopy of a fingerprint, the 2002 film Minority Report features extensive use of casual iris retina scanning techniques for both personal identification and point-of-sale transaction purposes. The main character changes his official identity by having his eyes transplanted, and later accesses a security system using one of the removed eyes. The movie Gattaca portrays a society in which there are two classes of people, those genetically engineered to be superior, termed valid, and the inferior natural humans, invalid. People considered valid have greater privileges, and access to areas restricted to such persons is controlled by automated biometric scanners similar in appearance to fingerprint scanners, but which prick the finger and sample DNA from the resulting blood droplet. The Disney Pixar 2004 film The Incredibles shows a scene where Mrs. Incredible visits Edna Mode, a fashion designer for superhero costumes, at her mansion. Edna Mode enters her lab by biometrically identifying herself. She takes off her glasses, has her eyes scanned, and uses her voice in order to get into the lab. The television program Mythbusters attempted to break into a commercial security door equipped with fingerprint authentication as well as a personal laptop so equipped. While the laptop system proved more difficult to bypass, the advanced commercial security door with live sensing was fooled with a printed scan of a fingerprint after it had been licked, as well as by a photocopy of a fingerprint. In Demolition Man, the character Simon Phoenix cuts out a living victim's eye in order to open a locked door which is fitted with iris scanning. A similar plot element was used in Angels and Demons, 2009, when an assassin gains access to a top-secret CERN facility using a physicist's eye. However, both of these examples are misleading to the audience since the methods depicted for enucleation, removal of an eye, from a corpse would not be a viable way to defeat such a system.